Okay, we're back to next studying section. Um, Going to study resources and access in the cloud. In this section of the course, we'll look at the functional structure of Google Cloud. Google Cloud Resource Hierarchy contains 4 levels. And starting from the bottom up, there are resources, project, folders, and an organization node. At the first level is resources. These represent virtual machines, cloud storage buckets, tables in BigQuery, anything else in Google Cloud. Resources are organized into projects, which sit on the second level. Project can be organized into folder or even subfolder. These sit at the third level. And then at the top level is an organization node, which encompasses all the projects, folders, and resources in your organization. It is important to understand the resource hierarchy because it directly related to how policies are managed and applied when you use Google Cloud. Policies can be defined at the project, folder, and organization node levels. Some Google Cloud services allow policy to be applied to individual resources too. Policies are also inherited downward. This means that if you apply a policy to a folder, it will also apply to all of the projects within that folder. Let's take a look at the second level of resource hierarchy project in a little more details. Projects are the basis of enabling and using Google Cloud services, like managing APIs, enabling billings, adding and removing collaborators, and enable other Google services. Each project is a separate entity under the organization node, and each resource belongs to exactly one project. Projects can have different owners and users because they are built and managed separately. Each Google Cloud project has 3 identifying attributes: a project ID, project name, and a project number. Project ID is a global unique identifier assigned by Google that can be changed after creation. They are what we refer to as being immutable. Project ID are used in different contexts to inform Google Cloud of the exact project to work with. Project names, however, are user-created. They don't have to be unique and they can be changed at any time, so they are not immutable. Google Cloud also assign each project a unique project number. It's helpful to know that these Google-generated numbers exist, but we won't explore them much in this course. They are mainly used internally by Google Cloud to keep track of resources. Google Cloud's Resource Manager 2 is designed to programmatically help you manage project. Manager Tools is an API that can gather a list of all the projects associated with the account, create new projects, update existing project, delete project. Can even recover project that is previously deleted and can be accessed through the RPC API and REST API. The third level of Google Cloud Resource Hierarchy is folder. Folders let you assign policy to resources at a level granularity you choose. Granularity you choose. The resources in a folder inherit policy and permissions assigned to that folder. A folder can contain project, other folders, or a combination of both. You can use folders to group projects under an organization in a hierarchy. For example, your organization might contain multiple departments, each with its own set Google Cloud resources. Folder allows you to group these resources on a per department basis. Folder also gives teams the ability to delegate administrative rights so that they can work independently. As previously mentioned, the resources in a folder inherit policy and permission from that folder. For example, if you have two different projects that are administered by the same team, you can put policy in a common folder so they have the same permission. Doing it the other way, putting duplicate copies of those policies on both projects could be tedious and error-prone. If you needed to change permission on both resources, you would now have to do it in two places instead of just one. To use folders, you must have an organization node, which is the very topmost resource in the Google Cloud hierarchy. Everything else attached to that account goes under this node, which includes folder, projects, and other resources. There are some special roles associated with the top-level organization node. For example, you can designate an organization policy administrator so that only people with privilege can change policy. You can also assign a project creator role, which is a great way to control who can create projects and therefore who can spend money. How a new organization node is created depends on whether your company is also a Google Workspace customer. If you have a workspace domain, Google Cloud Project will automatically belong to your organization node. Otherwise, you can use Google Identity, Cloud Identity, Google's Identity, Access, Application, and Endpoint Management platform to generate one. Once created, a new organization node will let anyone in this domain create project and billing account just as they could before. Folder underneath it and put project into it. Both folders and project are considered to be children. I haven't finished yet. To be considered to be children of both folders and project are considered to be children of the organization node. Hey. When an organization node contains lots of folders, projects, and resources, a workforce might need to restrict who has access to what. To help with this task, administrator can use Identity and Access Management, or IAM. With IAM, administrator can apply policy that define who can do what and on which resources. The who part of IAM policy can be a Google account, a Google group or service account, or a Google identity domain. A who is also called a principal. Each principal has its own identifier, usually an email address. The can do what part of IAM policy is defined by a role. An IAM role is collection of permissions. When you grant a role to a principal, you grant all the permissions to that role contains. For example, to manage virtual machine instances in a project, you must be able to create, delete, start, stop, and change virtual machines. So these permissions are grouped into a row to make them easier to understand and easier to manage. When the principal is given a role on a specific element of a resource hierarchy, the resulting policy applies to both the chosen element and all the elements below it in the hierarchy. You can deny rules that prevent certain principals from using certain permissions, regardless of the roles they are granted. This is because IAM always check relevant deny policies before checking relevant allow policies. That's a good statement. Deny policy, like allow policy, are inherited through the resource hierarchy. There are three kinds of roles in IAM: basic, predefined, and custom. The first role type is basic. Basic roles are quite broad in scope. When applied to a Google Cloud project, they affect all resources in that project. Basic roles include owner, editor, viewer, and building administrator. Let's look at these basic roles a bit more detail. Project viewer can access resources but cannot make changes. Project editor can access and make changes to a resource. And project owner can also access and make changes to a resource. In addition, project owner can manage the associated role and permission and set up billing. Often, company wants someone to control the billing for a project but not be able to change resources in the project. This is possible through a billing administrator role. A word of caution: if several people are working together on a project that contains sensitive data, basic roles are probably too broad. Fortunately, IAM provides other ways to assign permission that are more specifically tailored to meet the needs of typical job roles. This brings you the second type of role, predefined role. Specified Google Cloud Services offer sets of predefined roles, and they even define where those roles can be applied. Let's look at Compute Engine, for example, Google Cloud product that offer virtual machines as a service. With Compute Engine, you can apply specific predefined roles such as instance admin to Compute Engine resources in a given project, a given folder, or an entire organization. This then allows whoever has these roles to perform a specific set of predefined actions. But what if you need to assign a role that has even more specific permission? Then that's when you use a custom role. Many companies use the least privilege model in which each person in your organization is given a minimal amount of privilege needed to do the job. So for example, maybe you want to define an instant operator role to allow some user to stop and start Compute Engine virtual machine but not reconfigure them. Custom role will allow you to define those exact permissions. Before you start creating custom roles, please note two important details. First, you need to manage the permission that define the custom role you have created. Because of this, some organizations decide they rather to use the predefined role. And second, custom role can only be applied to either the project level or organization level. They cannot apply to the folder level. Okay. Imagine you have a compute engine virtual machine running a program that needs to access other cloud service regularly. Instead of requiring a person to manually grant access each time the program runs, you can give a virtual machine itself the necessary permissions. This is where service account comes in. Service account allow you to assign specific permission to a virtual machine so they can interact with other cloud services without human intervention. Let's say you have an application running virtual machine. One second. Okay, let's say you have an application running a virtual machine that needs storage data to store data in cloud storage. But you don't want anyone on the internet to have access to that data, just that particular virtual machine. You can create a service account to authenticate that VM to cloud storage. Service accounts are named in the email are named with an email address, but instead of password, they use cryptographic keys to access resources. So if a service account has been granted Compute Engine's instant admin role, this will allow an application running in a VM with that service account to create, modify, delete other VMs. Service accounts do need to be managed. For example, maybe Alice needs to manage which Google account that act as service accounts, while Bob just needs to be able to view a list of server accounts. Fortunately, in addition to being an identity, a service account is also a resource, so it can have the IAM policy of its own attached to it. This means that Alice can have the editor role on a service account, and Bob can have the viewer role. This is just like granting role of any other Google Cloud resource. Okay. When new Google Cloud customers start using the platform, it's common to log into Google Cloud Console with It's common to log into Google Cloud Console with a Gmail account and then use Google Group to collaborate with teammates who are in similar roles. Although this approach is easy to start with, it can prevent challenges later because the team's identity are not centrally managed. This can be problematic if, for example, someone leaves the organization. With this setup, there's no easy way to immediately remove a user access to the team's cloud resource. With a tool called Cloud Identity, an organization can define policies and manage their user and groups using Google Admin Console. Admin can log in and manage Google Cloud resources using the same username and password they already use in existing Active Directory or LDAP system. Using Cloud Identity also means that when someone leaves an organization, administrator can use the Google Admin Console to disable their account and remove them from group. Cloud Identity is available in a free edition and also in a premium edition that provide capability to manage mobile devices. If you are a Google Cloud customer who is also a Google Workspace customer, this functionality is already available to you in the Google Admin Console. There are 4 ways to access and interact with Google Cloud: the Google Cloud Console, the Google Cloud SDK and Cloud Shell, the API, and the Google Cloud app. Let's explore each of these now. First is the Google Cloud Console, which is Google Cloud Graphical User Interface, or GUI, that help you deploy, scale, and diagnose production issue in a simple web-based interface. With the Google Cloud Console, you can easily find your resources, check their health, have full management control over them, and set budget to control how much you spend on them. The Google Cloud Console also provides a search facility to quickly find resources and connect to instances via SSH in the browser. Second is through the Google Cloud SDK and Cloud Shell. The Google Cloud SDK is a set of tools that you can use to manage resources application hosted on Google Cloud. These include the Google Cloud CLI, which provide the main command line interface for Google Cloud product and services, and BQ, a command line tool for BigQuery. When installed, all of the tools within Google Cloud SDK are located under the bin directory. Cloud Shell provides command line access to cloud resource directly from a browser. Cloud Shell is Debian-based virtual machine with the persistent 5 GB home directory, which makes it easier to manage Google Cloud project and resources. With Cloud Shell, the Google Cloud SDK, G-Cloud command, and other utility are always installed, available up-to-date and fully authenticated. The third way to access Google Cloud is through Application Programming Interface, or APIs. The services that make up Google Cloud offer APIs so that code you write can control them. The Google Cloud Console includes the tool called the Google API Explorer, which shows which APIs are available and in which versions. You can try this API interactively, even those that require user authentication. So suppose you have explored an API, you are ready to build an application that uses it. Do you have to start coding from scratch? No. Google provides cloud client libraries and Google API client libraries in many popular languages to take a lot of the drudgery out of the task of calling Google Cloud from your code. Languages currently represented in these libraries are Java, Python, PHP, C#, Go, Node.js, Ruby, and C++. And finally, the fourth way to interact with Google Cloud is with the Google Cloud app, which can be used to start, stop, and use SSH connect to Compute Engine instance and see logs from each instance. It also lets you stop and start Cloud SQL instances. Additionally, you can administer application deploy on App Engine by viewing error, rolling back deployments, and changing traffic splitting. The Google Cloud app provides up-to-date billing information for your project and billing alert for projects that are going over budget. You can set up customizable graph showing key metrics such as CPU usage, network usage, requests per second, and server error. This app also offers alerts and incident management. You can download the Google Cloud app and cloud.google.com/app. Wait, why this are not checked? Why is it not check? Also I have to, okay. Alright. So I have to let the video finish. Go on. Okay, there you go. Let me see these. Okay, we can stop here and do the lab on the next one.